И еще раз привет. Ну что, нам остался крайний на сегодня рывок. Пожалуй, самый насыщенный, самый интересный. Ведь сегодня мы сейчас поговорим об одном весьма нетривиальном подходе к спасению некоторых из наших приложений. Сейчас перед нами будут выступать не один, а сразу два докладчика с совершенно разных концов Земли, включая даже те, где сейчас только раннее-раннее утро, в отличие от заснеженного и темного Новосибирска. А поскольку докладчики англоговорящие, дальше, если вы не возражаете, I will speak from my heart. It's not a secret that many developers, if not the majority of them, used to think that reactive approach and reactive tools are all about new applications. It is applications written from scratch. It seems obvious that a legacy application cannot easily become a reactive one due to its nature. Nevertheless, there are cases that allows us to make some profit out of distributed legacy applications with reactive approach as well. It is my great pleasure to welcome here at Snow One two well-known experts in the field of reactive programming. Mary Grygleski is a senior developer advocate and software engineer at IBM and well known for being the president of Chicago Java user group. And Fabio is a software engineer and community leader based in Amsterdam. He runs 2,000-member strong Reactive Amsterdam meetup and annual Kubernetes Community Days conference. So, Mary and Fabio, please welcome. I'm really happy to see you here on the conference, and I'd like to ask a couple of questions just before we start, just to make the context of our future session. First of all, can you please tell me, for example, Mary, if you don't mind, I will start with you. How did the idea for the talk come to your mind? Or
Sure. So I'm working for IBM, and there's one of the themes that we are trying to push forward, like with enterprise systems, is to do application modernization. So it's basically taking, legacy applications to see how we can transform it and kind of use the cloud native way and like fit into the modern infrastructure. So because I've been advocating for reactive is one of my areas of advocacy. So I just thought I started thinking about the idea, and of course too in our particular case too. Now I spoke with Fabio, who I met in Rome in 2019 at the Co-Motion. We've always been exchanging messages on reactive, so I thought it might be good to come up with a topic and along the lines of like modernizing old applications. So that's essentially how I kind of thought of it. And then we both started talking about it. It was kind of exciting too, to be kind of being creative, thinking of something new. So yeah.
I've got it. Thank you a lot. And Fabio, can you please share us on how or who will find this talk most useful? What do you think about it?
Like you introduced at the beginning, there is a conception that reactive technologies and reactive approach are only useful if you're developing something from scratch. In fact, this is hardly the case. We believe that bringing a reactive approach to your existing application is very beneficial. So I think someone who feels a little bit stuck with a legacy application, difficult to modernize, I'm sure they would find for sure a lot of inspiration in our talk.
Okay, I hope so. So I think we can move on to the first part of our session. So let's start with the session as it is. Okay, this time we'll see you sometime later.
Have fun.
Let's start.
Thank you.
Hello, welcome to our talk. Talk today by myself, Mary Grygleski, and Fabio Tiritiko. Today is an interesting emerging topic presentation called Retrofit Your Legacy Java App with a Reactive Flow Pipeline. We'll take a look at how Reactive can be applied to transforming an old traditional legacy Java app. And this is our agenda for today. We'll have a quick introduction, and then we'll go into talking a bit too about a bit of history as kind of setting up the stage as to why we have this talk, discussing from the perspective from an enterprise JVM applications point of view. And then we also explore into a bit of the complex problems in today's world that's evolving, that's becoming more and more complicated, needing more and more data. Everything is just come in bulk. We have so much to sort through. So what would be a good approach is what we're proposing here, which is the fourth section, is about some solutions that we can be using, and it's basically leveraging on the reactive approach. And then Fabio will then take us into an in-depth look into an experiment that we have done, and mostly merits to Fabio, who spent a significant amount of time working through some of the inner things. And so that will be Fabio area. He will spend more time with you on that. And then after that, we will come together and give a conclusion to this whole experiment on the reactive Java kind of experience that we have. So, all right, so let's begin. A quick introduction. I'll just since I'm talking, let me introduce myself. I'm Mary Grygleski. That's my Twitter handle, and I'm a senior developer advocate at IBM in the Java, open source, and cloud space. I'm also, by night, president of the Chicago Java Users Group, as well as a few other user groups in the Chicago area. So now to you, Fabio.
Yes. Hi, everybody. And thanks for having us. My name is Fabio Tiritiko, and Twitter handle is TicoFab. It's a lot easier to pronounce than my family name. And I am based in Amsterdam, where I work as a software engineer, now currently actually in an engineering manager position. And I am the founder of this community, Reactive Amsterdam. So yes, the topics of today's talk are really, really dear to my heart.
Thank you, Fabio. So with that, without further ado, I'm going to start. So why, right? And I've been speaking at a lot of conferences, and so has Fabio, with a deeper experience in Reactive too. And I'm sure, Fabio too, like myself, we've constantly been asked by our audience as to, well, how can Reactive be of use in today's world? So one aspect that we have been exploring into is really looking into enterprise JVM applications. These are applications that are powering the world's huge kind of back-end applications in production, in big financial places, in insurance company, in manufacturing places, you name it, they are there. So their mission is actually very important for the company. They do a lot of things on, for example, very typical ones is like e-commerce systems that essentially you have customers trying to shop for something, catalog, and then you order. To order, as we all know, is not a simple thing. And then, of course, with this order and with today's world, we are not just paying by cash, and we are also doing credit card, or now even more like kind of cashless payment, or what cardless payment. I'm sorry. And so all these things, they are very complicated and require a lot of security and all these things. And as you can see, is really complicated. But the traditional way of doing things is that before hardware has been able to get caught up, when we're having single CPU or having like parallel processing of multiple CPUs, but essentially kind of like a single thread handling per CPU type of scenario, applications were developed in a very monolithic fashion. So everything too we could be processing is all in the same JVM, if it's taking Java. And they are all like doing things within the JVM, let's say order entry. And if you have an order, you need to talk to send your order over to your credit card, verify all your transaction. They will actually essentially hold up a thread, and you just like have to sit there and wait. And that type of, it's just an example of some of these monolithic applications in their runtime. The effect of how it affects the whole system is just not designed to be very scalable, not very flexible at all. And not only that, on the design side, we run into that problem in runtime. But the thing is, too, is that we also rely on a huge operation teams to help us, too, with the building part, not only building. In the testing phase, too, we will be like having, the different development version of your code, or have your QA running a separate version. And then you have certifying all that before you go into production. Then, so overall, too, the maintenance of such application is very high. And it's also not very flexible. It almost seems like the world must stop if you need to upgrade any part of your system. And that's kind of like the whole kind of issue with it. And of course, too, the data aspect, too, is kind of like hard for it to be kind of like go through different states without being easily able to get updated the state changes between these different parts. So let's go on. And of course, too, not to mention the fact is that there's also the concurrency aspect of processing that present itself a lot of challenges. So those are kind of like some of the traditional enterprise applications that we can kind of think of using a reactive approach to solve. Then we talk about the solutions that we're proposing is to use this reactive approach. Is that in today's world, then of course it's microservices has already been popular since I'd say in the 2010s kind of time frame. And so those are solutions of using this reactive approach. And actually microservices itself too is kind of perfect for letting the reactive or be adopted by the reactive way. They kind of both are kind of work together very well. A reactive system itself is by nature not tightly coupled too. So microservices is like a perfect kind of architectural approach that reactive systems can use. Oh, actually, I should also add too is like also the serverless aspect to it. It deals with the deployment part too, and in the serverless cloud native world too, it's also very suited for this reactive approach. And of course too, with microservices, everything kind of broken out and no longer like all together. Then you can essentially do your upgrading without one part can be down while other parts are still running. So that kind of is very, very conducive for the reactive approach. And of course, too, there's also the traditional operations part is no longer, the case. We're kind of using modern DevOps and infrastructure to for the deployment, building, continuous integration, and deployment part. And now, too, if you think of reactive, too, is basically enable concurrency without us, the developers, still having to worry about the mechanics of threading concern, because all of the threadings are now being handled by the libraries, by the reactive framework or libraries or toolkits, so that developers can then focus on actually the business operational side. Now, the thing is with using reactive approach is basically we're proposing is to build and transform some legacy applications. We're identifying parts of it and allowing the data to be flowing through different pipelines. And that's the area that Fabio will be demonstrating for us is to a case in which we're building using different implementation of a reactive pipeline and different reactive libraries to implement this pipeline. And so I will pass the baton over to Fabio to talk about this particular use case.
Yes, thank you very much, Mary. what we are going to look at is this hypothetical situation where we're talking about some data pipeline, and there's going to be some processing happening. The first legacy processor will read, consume data from the first Kafka topic, and then the second processor will do some additional processing on it after it has received the output of the first processor. And finally, the second Kafka topic will be where our process data will end up. And what's important is in this entire pipeline, we are using concepts coming from the reactive streams idea, where reactive streams is a standard that has been part of the JDK since JDK 9, I believe. And one of the most important consequences and benefits of using this standard is back pressure. So what we'll see is that the entire process only does actual something if there is demand from downstream. So in this concrete example, let's say if the legacy processor number 2 doesn't have enough capacity to process all the potential incoming data, the first processor, legacy processor number 1, will be reacting to this situation by simply stop sending data and awaiting for legacy processor to be ready to process more information. And this is crucial in large systems where many pieces interact with one another, as fast producers might boggle down slow consumers. And so in order to avoid this sort of overflowing situation, we have these pipelines that employ back pressure all the way up to the source of the data. And now let's go look at some code and some demo. Here we are. You should be seeing my screen now. And what you are seeing now is, in fact, the GitHub repository with the code for the demo that you're about to see. As you can see, there's these 2 legacy processor 1 and legacy processor 2 are our projects. And then there's 2 other folders. One is about infra, is a simple Docker Compose file that will spin up our Kafka infrastructure. And sources producer is a project that will simply put some random data on Kafka, so the first legacy processor has something to consume. Now let's see this in action. Here we are. There's our infra directory. Let's spin up our infrastructure. This is going to start our entire Kafka backend. Yeah, there it is. Now we have a running Kafka cluster on my local machine. And so let me start the sources provider, which will start push data into our Kafka topic. This is going to be just, let's see, there it is, 1 record per second containing just that specific timestamp, as you can see. And this guy is just going to keep producing as we go. So let's first look a little bit at the code before we started. What you are seeing now on screen is the implementation, the actual starting point of the first legacy processor. It's in Scala, and it uses a reactive stream implementation called Akka Streams. Akka Streams is based on Akka, a product from Lightbend, an open source product from Lightbend. And the idea of Akka Streams is that implements in the reactive stream specification. So there are a lot of different connectors that we can use in part of Akka streams. In particular, here we are going to use the connector that allows us to connect to a Kafka topic and consume events from it. And this little snippet here, this is the entire thing, the whole thing that we really need to look at. What this processor is going to do is going to, okay, after instantiating some configuration setting, like which topic we are going to submit to listen to, here we are creating our stream, which starts considering our Kafka topic as a source of items. And then for each item that comes in, we are first simulating some processing. In this case, we are just extracting the string value, and then a little step here to convert the string into bytes. And then we are going to put this data into a RSocket sink. Now, a little introduction to RSocket is necessary here. RSocket is a protocol alternative to HTTP. So at the same level it's an application level protocol, basically built with the reactive stream concepts in mind. So there are solutions that leverage the reactive streams idea into HTTP, making it a back pressure enabled transmission of data across services, but RSocket is born with it. And this is all you need to know, really, for now. But RSocket is really an interesting project. In fact, RSocket stems from Reactive Socket. That's what it was called in the beginning. And it's above TCP, so it makes a good candidate for intercommunication between two services. And in this case, this legacy processor one, what we have done is, let's say this process item function method here represents a legacy type of processing. Maybe we are dealing with indeed some legacy logic that we have and we don't want to change, and all we want to do is wrap it inside a string. And then the data that comes out of it, we are going to offer to this RSocket sink. We are going to look at the implementation of this a little bit later. If we look for a second at the second legacy processor, which you are seeing on my screen, this is a Java application, which again, it will create a Kafka producer in this case, because the output is producing data onto a second Kafka topic. And then this code that you see here is about, let's say, this block here is about creating a RSocket receiver. So once the first legacy processor finds a valid connection to the receiver, it will start pushing data through. And what happens with the data that we receive is right here, is this bit. For each item that we receive from the first legacy processor, we are going to extract its string content and simulate some work. This is, again, simulation of some legacy processing logic. This processing actually is maybe a little interesting to look at. It's just down here. It will basically make our machine and our thread sleep for a random number of seconds. We'll see later why a random. And after we are done processing, we are going to publish the data onto a second Kafka topic. What's interesting to notice here is that only at the moment when we return from this method, once the execution of this logic highlighted now has completed, This is going to be the signal to the first legacy processor that we are ready to receive more data. And this syntax here, flux.empty, you are probably familiar with it if you have used the Project Reactor or Spring Boot-esque applications. You are probably familiar with this logic. And this is all I want to say for the moment about this legacy processor. Let's try and give these two guys a spin in this window here. So let me first start. Let me just check that our sources producer is still producing data on Kafka. So let's spin up our first legacy processor. Now, this processor has started and is trying to connect to a RSocket receiver, but at the moment there's none running. So what's interesting already to notice is that because there is no server running, then this entire stream is not consuming anything because this particular component is not asking for anything to consume. So by going all the way back to the source, we are not consuming anything from Kafka. This consumption will start when we trigger the second legacy processor. What we should see, if the demo gods help us, is that the first legacy processor will connect to the listener and start consuming events from Kafka. There it is. So here, what you could see is that when an item is received on the second processor, then there is this random delay. So you see 2 seconds, 3 seconds, and the first processor is only reading messages from Kafka as there is availability from the second processor. And so you see that they really go hand in hand. The entire thing is protected in this sense. We are only consuming data when there is some need for it. And I just want to, this concludes our demo. I just want to spend 1 more minute. For those of you familiar with Akka streams, it's an incredibly powerful ecosystem, incredibly rich. There are Kafka connectors, HTTP connectors, or connectors to connect to basically most of your potential technology underneath in a reactive way. But interestingly enough, there isn't an official connector for RSocket. So what I have done, I have created these 2 RSocket sync and sources, get an inspiration. There is a blog post actually on the Lightman website, which I used as a inspiration and then built on top of that. This code you see here is the RSocket sync that we are using. And the idea is this is the area where we create the connection to the RSocket receiver. And then what I want you to look at is basically 2 things. This method here that we have overridden on push lets us write the logic of when we should retrieve items from the stream and when we should get then the next one. So in this case, this grab is the signal to grab an item from upstream, and then only so we are grabbing some payload here, Here, this is the line where we are sending the payload further. And then only when there is a request, we are asking for a new item that will be triggered from above. And the code is online, so you can look at it. This is all for our little demo. And now I would like to share with you a couple of conclusions about this experience from building this pipeline. So the good things and the bad things I found. Well, first of all, I have some experience with reactive streams already, but if you haven't been exposed to them, to this kind of standard, it really is incredible. It enables you to work with different technologies. Not only on the JVM, you could have a reactive stream implementation in Python, for instance. Why not? And still keep the streaming semantics of back pressure all the way through the pipeline. But something that is not great is that different implementations, as you can see, are not yet very easy to get to work together in the same process. Our socket is a great technology, but unfortunately, documentation is very limited. I asked some things online and I got help from the helpful contributors, but mostly pointing to the examples online, which are certainly useful, but then again, limited, and you have to do a lot of work to figure things out as you go. I also didn't like very much that the Java implementation relies on Project Reactor, because you might simply not want that. You might want to use a different implementation. And if you are in a Spring sort of world, this is perfect. It is absolutely perfect for you. It will just mix seamlessly with Spring Boot. In fact, there's books written about it. But if you don't particularly like Project Reactor, you're still stuck with it. So it's just a dependency. In fact, my conclusion is that, in fact, while not built for this streaming purpose, if you mix HTTP with some underlying streaming semantics, and there are some projects that have done that, like Akka HTTP, well, this solution might be a more efficient and faster way for you to modernize your legacy application. And this is all for me, and maybe we can share some conclusion together with Mary at this point.
Sure. Yeah. Thank you, Fabio. It's a great demo and very clearly explained. Thank you. So yeah. And we're kind of looking at this whole pipeline and we're wondering, this is like a sample implementation. Could we actually have other implementations? I think, as you mentioned about, right, we could actually write maybe the legacy processor too, could be like in Python, in even JavaScript, maybe Node.js.
For sure.
So I think it basically we're trying to illustrate is that with the reactive streams kind of approach, it's actually make your application a lot more modular, so to speak, like modularize. If you're writing microservices, you can actually have the legacy processor as one microservice and the other legacy processor is another one. And so you can see that they all connect with each other through messaging. And in this case, we, as Fabio has illustrated, it will be in our socket and you can plug different things in, plug and play. So it's actually a very flexible approach. And that's what we also like about our Reactive. And it's because of that capability that kind of enables us to do things more efficiently too.
Indeed.
So, yeah, exactly.
Indeed.
So yeah. And then also maybe one last kind of conclusion is that, well, how about like Project Loom that's kind of scheduled now for Java 18, I believe. And
that's right.
So there's still a couple more versions before it will be released. But we wonder, right, with virtual threads, carrier threads too, right? And we wonder how it would be. And I've also like heard about people talking about, Project Loom's coming out, Reactive's gonna be dead. But I don't think so, right? I mean, Reactive, so to speak, we're handling the problem domain on a different level, on a more abstract level, but the virtual threads are a bit more of the lower level, dealing with more of the towards more of the primitive kind of more threading kind of that direction. So then it's more like they both should be complementing each other is what I'm
exactly thinking. I fully agree. I think Project Loom is definitely going to be a very, very powerful addition to the JVM. In my personal opinion, I think is going to be very useful for low-level logic. So maybe if you are a library maintainer, or maybe if you're the maintainer of one of these reactive library yourself, this is going to be really, really useful. But for a lot of users, simple users of these libraries, I think we will still prefer to operate at a higher level than going back to creating and spinning up threads ourselves, even if they're virtual. We'll see. We'll see how it plays out. But yeah, certainly something to definitely keep an eye on.
Yeah, very true. Yeah, wonderful. Yeah, it's been a great conversation too in our presentation. Hope everybody enjoys it. And
these are a couple of links to lots of things we've mentioned. The first one is the sample code that I've shown you. Our socket, Quarkus, Docker, lots of technologies that we mentioned. And I believe this is all from us. So thank you very much. These are our contacts and our links.
That's right. Yeah. Thank you all for attending our talk.
Yeah. So goodbye everybody, and till the next time.
Yeah.
Bye.
Bye-bye.
Hello. Good. Yeah. Great.
Now, we certainly hope that you enjoyed our talk and that it was a bit of an inspiration for what concerns starting using or exploring these reactive technologies, reactive approaches. And I don't know, maybe some of you have already experimented with that, in fact, and we would like to have the next few minutes as well as a bit of an interactive moment. So personally, I am super interested in hearing maybe your experience or your questions or your comments on using reactive technologies. So if you have some, please do leave them in chat and let us know. We can take it from there.
Yes. Yeah. Same here too. I really would like an interactive discussion too, and ask questions and share with us your experience in Reactive in particular, or even just working with concurrent applications. How do you handle them, right? And those are more realistic way of handling today's computing needs. It's all about distributed concurrency system underneath the hood. Like think of like e-commerce systems. That's all all of these that's utilizing what reactive systems promises to deliver. So so I would be also interested to hear about your experience too.
Yeah.
Right.
Yeah, absolutely.
Right.
And so while we wait for questions coming in, maybe I was wondering if Mary, you have worked a lot as a developer advocate for IBM. You've been there for already quite some time, and in fact, Reactive and the reactive world was one of your focuses of one of your topics. What is your perception from someone who is on the field, listening to developer stories or maybe helping them out? What is your perception on this reactive adoption? How do you see it changed over time? So what's your story with this?
Sure. Yeah, that's a really good question. Yeah, I've been doing Reactive for, I guess, 2 years now, almost kind of time frame. I'm finding that definitely there are lots of interest in this topic area because it's especially when it came out in the, I'd say like mid 2013, 2010, kind of mid in that time frame. So I think even to this day, there's still a lot of interest in it. But from what I've noticed is that the rate of adoption isn't that fast. And I think it's also because it requires like a fundamental paradigm shift. The programming level, it's this, we're talking about streams, we're talking about functional style of programming. So if you're more of a traditional enterprise Java application developers, you may not be as familiar with this semantics, the way how it's being done. That's one thing. And of course, too, then all of a sudden, like we're now dealing not with kind of formal data structure. We're kind of treating data as streams. So it's very different way of processing. And then we're dealing with the back pressure, all these things, the different models of getting data. So overall, I find that the rate of adoption isn't that high, but there's still a lot of interest in people wanting to learn about it because they've heard about all these benefits, especially in helping with distributed concurrent systems too. So that's what I've found as far as reactive systems goes. So yeah. And but I do find, for example, though, like if it's Android developers, they are actually more used to using RX Java. However, I think RX Java itself, right? It's actually, from what I'm doing too. At first, too, I thought reactive extension RX Java. I thought, well, it was reactive. Yes, true, it is kind of reactive, but I think fundamentally, it's still processing as a synchronous call underneath the hood, and that's something kind of still intriguing to me. But anyway. That's what I found out. So I think people are probably doing some reactive, but just kind of maybe not aware of it being like reactive if they are Android developers. So,
right. Yeah. I think in my own experience by running, this reactive Amsterdam community, I agree with that. I think adoption is for sure one of the factors that maybe slows it down is a bit of confusion. Like you said, there's many different technologies that try to make this reactive name theirs and say, I am reactive. Hey, I am reactive. I am reactive. But in reality, everyone means a slightly different thing.
yes.
So, the major confusion I see, that the most confusing point is this difference between reactive technologies, as in reactive programming versus reactive systems.
Yes.
And so I think RX Java that you just mentioned falls fully into the reactive programming camp. But then there's a lot of other principles that have to do with resilience and concurrency, distribution, that belong more to the design of reactive systems. And so, I fully agree with you. Adoption has probably been, it could have been faster if there was more clarity on these different camps.
Totally. Yeah. And I also have to admit too, when I first started learning about reactive systems, that was 2 years ago when I joined IBM, and they were saying, oh, can you help with the ACA? That at the time there was a partnership with Lightband. So I started learning. And of course, when you first started learning reactive systems, from the ACA side, it was actually very hard because ACA is not a simple infrastructure at all, right? All the libraries, and Fabio, you're an expert in ACA side. So it took me some time too. So I also would like to encourage the audience is that if you start learning reactive, and then if you work with ACA, don't give up. It may be confusing, but just take some time to get used to. Like essentially, it's a paradigm shift in your mind to kind of learn about this approach to computing. And as you said, Fabio pointed out, reactive programming is the programming aspect, but there's the reactive systems aspect that deals with problem solving on a higher level. We're dealing with system as a whole. How do they interact with one another? So yeah.
Exactly. Yeah, I would second that ACA, it really is a mind shift. Is a bit of a different idea how to build systems. But I want to also second your invitation to everybody go out and experiment with ACA and with reactive technologies and design at large. It's a really worth investment. In fact, I will say see, we were mentioning all these different technologies. There's RX Java, there's Akka, there's many others. There's or Microsoft Orleans, there's Vertex. They all claim a little bit of the reactive camp, and standards like reactive streams, which we talked about extensively, can be a very powerful unifying factor that brings all these technologies together, and most importantly, makes it easier to make them work together. Because if I have something built with Akka and you have something built with Vertex, like we have seen in our demo, it's not always very straightforward to make them work together. But by introducing standards, that could be a really nice step.
Yes.
In that sense.
Yeah, exactly. So I also feel that, right now we're kind of at the tip of the iceberg for this reactive technology. I guess we're still there at the tip because, there's opportunities out there, but it's just waiting to be uncovered, essentially. And I think developers like yourselves, in the audience, you're very creative people. We know we are. When we're developers, we're creating new things, new way of doing things. So I think it is kind of is full of treasures to be uncovered is how I'm looking at reactive technology. So it's exciting. So
that's for sure. I'm actually wondering if any comment came from the audience.
Yeah, that's right.
At this point.
Yeah, there are a couple of questions.
Sure.
Actually, I would start with this one. I think quite expected one. How to integrate reactive way with legacy blocking technologies like GDBC? Very popular question.
Yes, this is an incredibly popular question. So I would like to give two answers. The first one is looking at the future, and the second answer is looking at the present. The one looking at the future involves Project Loom. So when Loom comes in, and at the moment is a little more than an experimental feature, but eventually it will be a proper part of one of future JDKs. When Project Loom comes in and you are a JDBC user, then Loom will sort of make JDBC reactive for you with no additional effort from your side. So it will make things by default asynchronous, and that will be already a huge benefit if you are a JDBC user. And so this was the answer that was looking at the future. Now let's come back to the present. You have a JDBC app and you want to JDBC using app and you want to make it a little more reactive, a little more asynchronous. Most of these reactive libraries, for instance, Akka, but also RX Java, they have very flexible ways where you can take your blocking synchronous operations, like JDBC operations, and offload them, limit them to a different thread pool. So at the beginning of your service, your app, you reserve a special thread pool that will only be used to run synchronous operations. And when you do that, you make sure that the blocking world in your app is kind of separated nicely from the asynchronous world. And then, these two worlds can still communicate with each other, but the blocking stuff that is happening here, the evil blocking stuff, doesn't interfere with the asynchronous world here. So if you look at the existing reactive frameworks, you'll find a lot of flexibilities in that sense.
Yeah, that's right. And I also like to point out too, there's also a newer framework. Maybe some of you have heard of this Red Hat Quarkus. So Quarkus actually allows for the blending of imperative and declarative. It's essentially reactive. You can mix the two. So I think they also have, like the library itself also manages the imperative and the reactive side quite well. Although on the JDBC, I think on the database, I'm not exactly sure right now. However, on VMware or Pivotal Spring, they have the RDBC that's reactive database driver too, so that handles that. So, but yeah,
Exactly.
but that's what Fabio explained too about the separating out the evil one and the good ones, and kind of
Yeah.
I like that analogy. Yeah, that is very good. So yeah.
Yeah, sometimes it helps. The world is always many shades of gray, but sometimes it's as fun to look at it as black and white.
Yeah.
So let's do
True.
that.
True. Yeah.
Thank you very much for such wide and explaining answer. We have another question that I think is quite concerned with the notion of blending technologies. I think it's somebody's particular question of his job, probably. What about using a Reactive with Tomcat? We used to think that Tomcat is a blocking one and so on, but what if we want to make an application based on Tomcat, a reactive one?
I have never tried to do that, so maybe Mary has more experience with that.
Same too. I have not done yet Tomcat with Reactive. The two same. I haven't done it. So, but that's a very good question. Yeah. How would
Yeah,
you?
yeah.
Hmm.
I remember using Tomcat for the last time in 2012. So that's 9 years ago. And correct me if I'm wrong, but there was this paradigm of one thread per request. Is that still there? Is that still happening?
I
Each
think yes,
request.
and something is going to change in version, if I'm not mistaken, 3.1. This will be the version that is promised to support some reactive implementations, but I'm not sure really.
Okay, so probably Vladimir, you just gave us the best answer. The way to build the reactive app with Tomcat is wait for the next version.
Yeah.
It's probably the most efficient way.
Yeah. That's right.
I've just read it from the chat. Okay, we have one more question. One of the most popular, maybe, things about shifting the paradigm to reactive one is the problems concerned with debugging and testing applications built on different reactive implementation. So, returning to your Fabio experience with the application that you have shown us several minutes ago, can you please share your impression about testing and debugging an application based on RSocket as an application protocol?
Yes, thank you very much. Whoever asked this question, it's a really important one. There is no denying that debugging reactive applications is a little more complicated because everything, even 2+2, involves asynchronicity, callbacks, and delegating work, offloading work to another thread, and so it is undeniable that it is more complicated. There are. I remember someone built some tools to sort of make a reactive application more linear, sort of forcing, let's say you force your entire application to only execute on like one single thread when you are debugging. So that means that every operation basically becomes sequential, and then it's kind of easier to follow. But there is no universal answer to this. Frameworks like Akka and probably Quarkus, and Mary will tell us whether I'm right or wrong. Frameworks like Akka, they provide their own test kit, where you can plug this test kit in and can like give instructions of, for instance, wait for this result to be available, sort of asynchronous testing, and for instance outcomes that only will come in the future. But then again, each framework, each tool has its own way of testing. And to come to the demo that we had, RSocket I didn't find anything special there. I think, as I mentioned, RSocket is a fantastic tool, but definitely in its early stage, I didn't see much testing structure, testing instrumentation that you can use. In fact, I'm sure that if you wanted to write something like that and open a PR on GitHub and contribute with some testing help, they would love it. So yeah, it's a bit of a long answer, but that's the way I see things for now.
Yeah, thanks a lot.
Would like a
Okay.
distributed tracing. I'm sorry. Would like a distributed tracing. I haven't used as much, but I started looking in this distributed tracing tool like Zipkin, maybe a bit closer to, being able to help in a distributed environment. I think so. That might be something folks can also start looking into too. Is what I've read about and started looking into. So yeah.
Yeah, definitely. Some tools for open tracing and other things are, of course, of help. Okay, thanks a lot for this answer. There is another one. How to identify the parts of an application, of a legacy application, which are suitable for starting the modernization? The modernization in a reactive way. Where should we start?
Go ahead, Mary.
Good question. Yes. It's never easy. Yeah, something kind of older application, especially if it's a monolith, right? Something like one JVM is everything in there. I think, well, I myself, I have to say, testify, right? When I started working with Java in the 2000, early 2000 application, 2004 or 5. So that time was more servlets, Tomcat in those days. And certainly like WebLogic, for example. And so, yeah, it's not easy, I'd say. But I think from some experiences that usually huge systems like that, you may want to identify a part that's a bit easier, so to speak, right? That we know perhaps also like less use. So then you can actually start to isolate that and then draw up a plan, modularize all your components of your systems and perhaps use like a domain-driven design kind of a microservices recommended approach, right? Of draw up all your domain and then pick a component that's a bit easier. For example, I actually went to a talk in Chicago of a startup company. They have successfully transitioned from imperative to reactive using Akka. But their first step was to do like their batch processing systems because they do data science processing. So every night was the batch job. So they know that they can start with that component and isolate that and use Akka to actually implement them. And they became quite successful. They started simple too, so it's not too complicated. So once you kind of can roll that out, then you can slowly keep like modernizing the rest of your component. You have like a first one is, is successful, then it gives you a lot more confidence to kind of go forward. So pick something simpler to start with. It is what I think sounds like a good approach. Yeah. And what do you think, Fabio?
Yeah, totally. Start with something simple. In fact, in my job these days at work, we are busy with doing exactly that. Separating. I work for a e-commerce company, and we are busy separating some logic from a bigger process and move it into its own separate service. And a tool that we are finding invaluable is domain-driven design. So by mapping your business logic, the real world, mapping your business process into having your model, your software maps a model of the real world. You can define very clearly these boundaries, these bounded contexts. And so if you have a big process, a legacy one, and you are able to map it, a bounded context helps you isolate one chunk and move it out after having created maybe some interfaces between the two. So that's a very useful tool.
Okay, thank you very much for your answers. and thanks for the session at all. I think we can continue the discussion in the discussion room after the talk, and we'll see you there just in a couple of minutes. Thanks a lot.
Thank you very much, Vladimir. Thank you.
Vladimir,
Thanks.
thank you, the audience. Thank
Bye.
you. Bye-bye. Bye-bye.